Hey, thanks for joining me. Let's go ahead and take a look at page 2 of our review. This may be a little bit of video, but remember you can ahead and fast forward to the portions that you need if there are there, but I think there's information that would probably be helpful to most of you. So let's go. So when we deal with trigonometry, which is a very powerful tool of mathematics that allows us to study mainly right triangles, although at times we can utilize it in ways to even study triangles that are not right triangles that you'll learn over time. But right now we're really studying right triangles. So we have a nice little mnemonic device, very much like PEMDAS or Roy G. Biv, or one of those little things that you have learned over the years, SOHCAHTOA, and that helps us to remember. So remember, the sine is the ratio of the opposite side to the hypotenuse. So every time you see the letter O, that stands for opposite, which simply means the side that is far away. So if I'm sitting at angle A right here, then 7 is as far away as I can get. That would be opposite from A. And opposite from B would be 24. Or opposite from 31 here would be X. Or opposite 55 here would be 39. The A always stands for adjacent. That means the close one. So if I was standing at A, the adjacent side or the close side would be 24. At B, the adjacent side would be 7. In this case, the adjacent to 55 degrees would be X. Adjacent to 43 is just not marked, so we're not going to be using that. So that one would not have an A. It would not have this one either. That would mean, since there's no adjacent side labeled, I would need to use the sign in order to work on that one. And so those are really the values that we have. And of course, H stands for hypotenuse in every single case. Now, last but not least, keep in mind when we do that, the first letter right here is always the numerator. I'm going to go ahead and put right here numerator, or the top of the fraction. The first letter is the numerator, and the denominator, long word for the bottom of the fraction, is always the second letter. So it's always going to be the first one over the second one, numerator over denominator. So this tells me here to start at letter A and do the opposite side divided by the hypotenuse. So the opposite or far side is 7 and the hypotenuse is 25. Here, I'm just going to run down this line right here. The cosine is the close side or the A adjacent side, again, divided by the hypotenuse, which is, again, 25. And the tangent is opposite over adjacent. The far away one divided by the close one, but not the hypotenuse, the other one. Now, if we switch perspectives to B, we're getting the same information just from a different viewpoint. So now the opposite from B is 24. Of course, my hypotenuse remains 25. The adjacent from B is 7. The hypotenuse is still 25. And you should notice that the sine of one and the cosine of the other are the same. It's just because all of a sudden we have changed perspectives. That's all. And the tangent of B is 24 over 7. And you should again see that these two numbers are simply reciprocals because we have changed where we're standing and what our perspective is. So that kind of gets through the first part. Now let's get into the application of SOHCAHTOA. So I'm going to write that right here. So as I move my paper up the screen, I still have access to that little helper. So when I look right here, immediately what I can see is the hypotenuse is not in my story. I don't have that listed, so it can't be a sine or a cosine. In fact, it must be a tangent. And the definition of tangent is opposite over adjacent. Now I can either use a table, that yellow table that we've been providing many of you, or I could just come in here and grab this piece of paper. Now, some of you would just write 0.6 or something like that. I'm just saying it's really 0.6 with a lot of decimals behind it, but they're almost all zeros. So all I have left to do is if I cross multiply, 1 times x is x, and in the other way, I'd have 17 times 0.600, blah, 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 all of that stuff, right? But see, I don't hit clear. I just say, I want to take this number right here on my calculator, and I want to multiply it by 17. So I'm going to hit times 17. And I got 10.2, and I'm done with that problem. 10.2 And for us, we're usually saying if you could round to one decimal place or the nearest tenth, that would be sufficient. Okay, so going to the second question. Again, you'll notice that we do not have an hypotenuse that is here, so it's still a tangent, but we did something that makes this problem harder. And what we have found is that many of you guys are struggling when its tangent is opposite over adjacent, when the x value is in the denominator. So when I take the tangent of 55, I got 1.428, and I don't ever hit clear on my calculator. Now, different people do this differently, but I don't ever hit clear. I still have that number sitting there. So when I cross multiply, I get 1.428 equals x is 39. See, 1.428 times x is 39. So I need, since x is being multiplied by this 1.4 value, I need to divide both sides by 1.428 to cancel those out, and x would be whatever 39 divided by that is. But the cool thing is, I already have that number in my calculator, so what I'm going to do is I'm going to take my 39 and divide it by the answer. Now that answer was the 1.428. It was the previous thing I had asked my calculator for, and I got 27.3. X is 27.3. Now again, everybody has their own way. Now we're moving over to here. I now do have a hypotenuse in my story, so it's either going to be a cosine or it's going to be a sine. But the value that I have is very far away. That's opposite. This is hypotenuse, so that's going to be a sine. Now, this is very much like that previous question where the variable's in the bottom. That's going to make it a tiny bit harder. So we're going to take the sine of 43, and I've got that right here. That's 0.681 or 0.682 maybe. I'm going to cross multiply and get 0.682x is 33. And so then all I need to do is divide both sides by this 0.682. And I know that that's not a pleasant value for a lot of you, but 33 divided by the answer is 48.4. X is 48.4. Now, if you had rounded and said, well, I'm just going to take 33 and divide it by 0.682 instead of hitting ANS or answer, am I still going to get 48.4? Well, you can see that I do. I get that same value. It's just what happens is if you needed a little more accuracy, these numbers will probably be off a little bit because I didn't actually utilize as much accuracy, and that's okay. Now, moving along a little bit further, this particular problem uses the adjacent or the close side in the hypotenuse. So this is going to be a cosine. And the definition of cosine, of course, is adjacent divided by hypotenuse. So the cosine of 61, we're looking at 0.485. Again, we got a lot of problems with the variables in the bottom. That makes, these are the harder problems for you guys. And for honestly, for me too. I have to be a little bit more cautious when it's on the bottom like that. So I need to take 45. I'm just going to go ahead and go lazy this time. 45 divided by 0.485. And I got 92.8. Good enough. Okay, 2 more to go. Almost done with this little section. This is adjacent. This is a hypotenuse, so that's looking like a cosine to me. So the cosine of 50 is adjacent over hypotenuse. So the cosine of 50 we're looking at is 0.643. Now, this is a nice one because when we cross multiply, 1 times x is just x. So this time I don't have that extra step because as soon as I cross multiply, I'm done. I need to take this 0.642 guy right that I have here and multiply it by 74 because I'm cross multiplying. And I got 47.6. Last one, I've got the sine of 71 because this is opposite, this is hypotenuse, is opposite over hypotenuse. This is another one of those problems. It's the easier version because when I take the sine of 71, 0.946, Of course, because the variable's on top, when we cross multiply this direction, I just get x, and x is already by itself. So all I need to do is what happens when 0.946 is multiplied by 63. And I got 59.6. All right, we are almost done with this page because our last three go the other direction where I'm looking for that angle. So what I know is that this is a tangent that yields the answer 15/29. I know that this one is a sine because this is opposite over adjacent, but this one is opposite over hypotenuse. So I'm just going to go through and set these up. This one would be a cosine because this is adjacent and this is hypotenuse. Cosine of something. And so what happens is in our calculator, we need to use the inverse tangent. We need to use the inverse sine. This is like the going backwards. Instead of using the angle to get the ratio, let's go ahead and use the ratio to get the angle, okay? So in every single time, all I need to do now is take my calculator out and go backwards. So it is the inverse tangent, that's they telling the calculator, please go backwards, 15/29. And I got 27.3 degrees. Right here, this was the inverse sine. Some people will call it an arc sine. And that one was 41.1 degrees. And my last one over here, the inverse cosine, also known as the arc cosine in certain programs, 10 divided by 17 is 53.96. So I'm going to call this 54.0. But if you wanted to call it 53.97, I would be okay with that as well. We didn't really specify the kind of rounding that you needed, but clearly you're going to have some rounding because even if you wrote this all the way to the end, you technically wouldn't be correct because there's even more out there because this is not a nice number. It's not a rational number. It's like pi and it goes on forever. I hope that was helpful to you guys, and I will see you guys back in class. Bye-bye now.